Oh, oh, hey guys, play the intro. GD Master, blah, 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 blah. Okay. Hey, how are you guys doing? Hope you're doing well. Today what we're going to be talking about is number systems. Number systems. So we've dealt with numbers, we've dealt with negative numbers, positive numbers, decimals, fractions, many different kinds. Well, they all have a place. Um, they all have a system that they belong to. So today, please feel free to pause this video because I am going to be giving you some definitions that, you know, if you need to write it down, please pause it. So we'll start with natural numbers. So natural numbers are the counting numbers. So in other words, it's stuff you can count with your fingers. And believe it or not, you cannot count zero with your fingers. So zero is not a natural number. That's the big thing that tricks everybody. So natural is just 1, 2, 3, 4, 5, 6, 7, and so on and so forth. Now a whole number, which you've heard a lot, I've said before, you've been told before, round to the nearest whole number, whole number, whole number. Well, what's a whole number? Whole number is all the natural numbers and zero. So the only difference between whole numbers and natural numbers is zero. Whole numbers are included. Zero is included with the whole numbers. Okay? Natural, no zero, whole, zero. And as you can see, they got a little zero in the word whole. Looks like a zero, right? Yeah. Okay. So natural is the counting numbers. Whole numbers are the natural numbers and zero. Then we have integers, which we've dealt with lately. Integers are all the natural numbers, zero, and their opposites. So in other words, it's all the negatives, no decimals, no fractions, just negatives, -3, -2, -1. You can say -1,000,000, whatever. Zero, and then 1, 2, 3, all the naturals. This is not, so like, some people want to define this as the whole numbers and their opposites, but that's not true because zero doesn't have an opposite. So that's why we define it as the natural numbers, zero, and their opposites. So the opposites of the naturals, okay? Then we've got rational numbers, and this is where we're really heading with this unit. So rational numbers and irrational, we're heading to both of those. Rational numbers are any number that can be written as a fraction. So for the examples here, I wrote 2/3. Obviously that can be written as a fraction because it is a fraction. -0.5, square root of 9, because what is the square root of 9? It's 3 or -3. So that is a rational number. And 2.3 repeating. This is the one that tricks people because the 3's do go forever, but you can write a repeating decimal as a fraction, and we will learn that soon. The thing to notice is that these all encompass each other. So the rational numbers also are all the integers, they're all the wholes, they're all the naturals. Okay? Irrational is a thing all to its own. So irrational numbers are a number that cannot be written as a fraction. So they do not belong with the other four systems we've learned about. Irrational numbers, for example, are pi, 3.1415 goes forever but does not repeat. Okay. Also, a decimal like 0.38578, I think it's a 9, 2, something that goes forever but does not repeat, cannot be written as a fraction. And then the square root of 20. The square root of 20 goes forever because the square root of 20, I don't know what it is, right? It's got to be in between 4 and 5, 4 point something. But it does not simplify to something like the square root of 9 does. So I made this diagram for you to make things a little bit easier. So if you start in the middle, you've got N for natural, and that's 1, 2, 3. Then you've got W for whole. Notice this circle goes around also the natural numbers because all the natural numbers are included in whole numbers. And what do whole numbers add? 0. The next circle is integers, again around the whole and natural because they're also integers. But what do they add? -1, -2, -3. And then the rational circle goes around all the other things because rational numbers are integers, whole numbers, and natural numbers. But they add square roots that work. So like perfect squares, square root of 9, square root of 16. 3.4 repeating, where you have a repeating decimal, and they add fractions and decimals as well. And then our world all to its own is irrational numbers. Pi, 0.385, that goes forever. square root of 10. So irrational numbers don't belong here. Irrational numbers, remember, they go forever. They cannot be written as fractions. Okay, so this is a great diagram for you to use. So yeah, that's it for today. If you have any questions, let me know. Yeah, we've got to know our number systems with where we're going. So somebody hit the outro here. Okay. Oh, thought it would be over by now. How do I hit the... Hey, watch out for puddles. And